numbers, and we have principal quantum number. Today we'll do the second part, angular momentum quantum number or azimuthal quantum number. Angular momentum quantum number or azimuthal quantum number. Okay, this is being denoted by small n. It describes spatial distribution. This word I don't know whether you heard it or not. Spatial means in space. Spatial distribution of electron cloud. And the angular momentum of the electron. It actually tells us about the shape of orbital. The shape of orbital I'll draw later on. After 2 classes I'll draw it. We are writing orbital. And in case of principal quantum number, we have written orbit. Occupied by the electron. It is designated as small. This quantum number is also called secondary or subsidiary quantum number. After finishing, please tell me.
Sir,
Done,
can you
sir.
dictate once more?
This quantum number is also called secondary or subsidiary quantum number.
No, sir. From the first paragraph, only first and second line.
I'm telling you from first line. It describes spatial distribution of electron cloud and the
Okay, sir.
angular momentum of the electron.
So what is electron cloud?
Electron cloud, see, here, very interesting thing you've told. Electron we have considered is, I have told you that a small particle is associated with wave as well as the particle nature. So in this case, the electron does not exist in the form of particle, because particle will be like this, particle will be like this. But if it is a wave, then it will remain like, so it looks like a cloud only. Okay, so what it will look, electron cloud looks like the, you have eaten that one. No, we call it cotton candy. It's a type of sweet. No, they spun it across a small bamboo stick. Yeah, did you not eat
Yes, sir.
cotton candy? Huh?
Yes.
Yes,
Yes,
but
sir.
electron looks like this. Okay. Now, can I rub it?
Yes, sir.
So I'll come to the interesting part of this one. See here. For any given value of principal quantum number n, L can have, L is the angular momentum. It is angular momentum quantum number. Can have all the integral value. Integral value means whole number value. Values from 0 to n minus 1. Each value corresponds to an energy subshell or sub. See here. Suppose you have taken first orbit, quantum number is 1. It will have one subshell. If you have taken second orbit, first quantum number is 2, it will have 2 values. But it will, where from you start counting? From 0. So it will be 0 and 1. If you go to the third orbit, whose quantum number is 3, it will have 3 values. And this will be, you have to start counting from 0. So it will be 0, 1, and 2. Total numbers are 3. Okay. The subshells are designated S, S, P, D, and F. Now see, where from we got these alphabets? Out of 26 alphabets, why did you choose only S, P, D, and F? See, this is being done from an experimental result. What is that experimental result? So when we have taken the spectrum of the atom, when you take the spectrum of the atom, this spectrum, you know this electromagnetic radiations are trapped. And in this case, they have got 4 types of bands. Some are very sharp line. Some are broad, but it is bright. Some are spread to a large area, but the brightness is little less than this. And some is, you find, it is very faint. So these spectrums are being written as sharp, as it is bigger than this and bright, so we call it predominant. This is called diffused, and this is called fade spectrum. So every first letter of this spectrum is being taken. So S has come from sharp, P has come from predominant, D has come from diffuse, and F has come from fade. Okay. So now these things somehow is not being discussed in maximum books. But when we studied in our time, these books were very, very critical. So they used to write everything. So you should know. So I'll write here. Note. Okay. The alphabets. The alphabets S, S, P, D, and F, representing different subshell, has been obtained from the atomic spectrum. Spectrum pattern. What are those? I'll write now here. Sharp, predominant, diffused, and fade. So you should know. Because electron, we know electron has the same mass, same charge, but their behavior are not same. Okay? The behavior are not same. These behaviors depends upon the origin from where the electrons have taken part in this spectra. So from different places when they take part, obviously their behavior is also be different. See, we are the same human being, but as you grow up in different houses, our behaviors are different. So we do not behave, all of us, we do not behave same. Okay, so now, so I'll show you. This is not difficult. Okay, now so I'll write down like this. If the value of L is equal to 0, okay, then we'll write it as S subset. If L is equal to 1, then it will be P subset. If L is equal to 2, this will be D subset. Okay. If L is equal to 3, it will be equal to F subset. If L is equal to 4, okay, in your book you find it is written as G subset. If L is equal to 5, it will be H subshell. But we have not got the existence of any subshell with G and H. So these are now, till now, non-existent. These are still non-existent. So it is the future. If you can get it, then we can future will write like this. Okay, now see here. I'll write here now. Value of N. And this is value of L. And here you will write subset. See, if the value of N is equal to 1, so how many values it will have? It will have So right now here, number of L, and here you will write value of. So do not get confused. Here I will not write with digit, I'll write by spelling. See, it says that for any value of n, L will have same number of values starting from 0. So here it is 1. So how many value will get? Number of L. So it will be 1. And it will start from where? It will start from 0. All right. Then 0 stands for what? S. So what will be the name of the subcell? 1s. 1 has come from the quantum. If it is 2, value of, if it is the second principal quantum number, 2, how many values it will have? It will have 2 values starting from 0. So this is the first value and this is the second value. So this is before what? What will be the name of the subcell? 2s. 2 has come from here. And this will be 2e. If it is 3, it will have 3 values. Okay? And 1, 2 values. It will have 3 values. You will start from what? 0, 1, and 2. You start from here. 1, 2, 3, 3. This is one quantum number. 3. So it will be, what is the name of this one? 3s. 3, 2. See here. 1, 0 is S, 1 is P, and 2 is P. So now it is 4. It will have 4 values. Okay? It will start from 0, first value, second value, third value, and fourth value. So what will be the name of this one? It will be 4s, 4p, 4d. See, for 3 is what? F. So it will be 4. All right.
Yes, sir.
Then I'm running this. Now, what is the significance of L? Significance of angular momentum quantum number. So what is that? This indicates the number of subshell present in the main shell or orbit. Second, the angular momentum, no, not momentum, moment of the electron can be calculated by using the following formula. See here. What is the formula? Formula is L. Capital L is the angular momentum. Is equal to root over L, small l, L plus 1 into H by 2 pi. Okay. Say I want to calculate the angular momentum of this angular momentum of S electron. Okay. Now what is the value of L? See, L value of S electron is what? Is 0, because we write 0 for when it is 0, then you write S. So what will happen? Right here now. 0 into 0 plus 1 H by 2 pi is equal to what? 0. That is the angular momentum quantum number of L is of S orbital is 0. All right. So this is the we can calculate. So if you want to calculate for P electron, value of P is equal to 1. So this will be 1. So that we can calculate. This comes in your entrance exam. So you should know. Then third. Yes. The relative energies of various subshell. This is SPDNF. Depend upon the value of N and L. So what will be like this? See, energy of 1s is less than 2s. It is less than 2p. It is less than 3s, less than 3p, less than 3b, and not rotate. So this is the energy. Okay. Now next. Fourth, the shapes of various subcells present within the main shell or orbit. So that we will draw it later.
So can you please repeat the first line again?
This one.
Yes, sir.
Oh, see, when we know that the different number of the subcells present, then we'll be able to draw the shape of them. So this one I'll do after 2 classes because it comes later on. Okay, I'll draw it for you.
Okay, sir.
Then 5. It explains the fine spectrum of an. So I told you that initially when you got this type of line in hydrogen spectrum, we thought it's only single line. But when you have observed it under strong magnifying glass, we find no, in fact, it is not one. It contains many lines. So this is because of the electrons present in different subshells. So we have, I told you, what is the demerits of the Bohr's model? Bohr could not explain the fine line splitting. They have found different lines. They thought these are single lines. But when you place the atom in an electrical field and magnetic field, you find the line splits, which they could not observe it. So when you put them in electrical field, the line splitting can be explained only because of the presence of subshells. Because we thought that this is the orbit. The electrons, all the electrons are here, but actually not. They are in different positions. Means this electron cloud. Suppose you look at the sky. you find the clouds are there. But do you think all the clouds in the sky are in the same level? No, they are not in the same level. Some are lower, some are little higher, and some are very far. So obviously, when the rain falls from the cloud, they do not fall from the same height. They come from different heights. But when you look at the rain falling on the ground, we assume that all of them has come from the same height, but actually not. They travel different distances to reach the surface of the earth. Same is the case. We find this is the energy of, see, this both of them belong to the same orbit, but their energies are different. Means they are the distance for the nucleus is different, because we know energy depends upon the how far the orbit or orbitals are away from the nucleus. So these are the different information we can get it from the angular momentum quantum. So now we'll go to the third one. Third is magnetic quantum when you place an atom in magnetic field, in that case you'll find what about the lines are there, they've split further, which is known as Zeeman effect. Okay, so this magnetic quantum number, that is, we find the electrons are sensitive to the magnetic field. Okay, and what is magnet? What is magnetic field? It is an energy. And all quantum numbers are, what do you call it, quantum numbers? Because they related to energy. The word quantum has come from quantized, which is energized. So these are all related to energy factor. This quantum number is designated by the symbol ml. It explains the Zeeman effect. I told you, no? What is Zeeman effect? That if you have placed an atom in a magnetic field, after that you take a spectrum, then you find the initial lines, what you have seen that they have drawn, this splits further into very, very fine lines. Okay, so these are called Zeeman effect. That is under the influence of magnetic each subshell is further subdivided. What is, see, what is shell? And shell is same as orbit. What is subshell? Subshell is called orbital. And these orbitals further split. We can call it suborbital or we call it subshell. Okay, subshell. So this, see here, what is it written? Each subshell means what? S, P, D, and F. Okay, I'll write down here. I don't want that you should have any confusion, even though you are having online classes. Is further subdivided. Why does it divide? Under the magnetic field. Into orbitals. Now here we write. For each value of L, here L is the subshell. This. The magnetic quantum number ml or m. Some book they write ml, some book they write m. May assume all integral value from minus L to plus L, including 0. That is total twice L plus 1 Don't get scared. I'm telling you. I'll show you now. See here. This is the orbit. This is N, principal quantum. Electron is here. See here. So this is what? This is orbit. This is what? In this case, this is nothing but azimuthal quantum number or L. I told you, if this is the road by which you are coming from home, you can be present at a certain fixed time. You can be present only in very specific part of the road. Suppose it is your house. So your father has started, you say it is one way in the morning line you have seen. The father has started from here and is coming by this. So at that point of time, it is here. You were here in the car. So this is what? This is L. Now, as he is driving the car and it's one way, depending upon the which space is vacant, he will come. He may drive in left, he may drive in the middle, he may drive at the right hand side. So when I place it in the magnetic field here, let me magnify it here. When I place it in the magnetic field, see these electrons, here the energies of all the electrons are same. Okay, now when I place them in the magnetic field, you'll find this field is going to separate this electron cloud. Separate the electron cloud. So if this value is minus L means what? Don't go by the theory of minus plus. It's not the question of addition and subtraction. It is the question of your level. If this is the zero level, then if this electron is dead, is below the specific level. Just like that, you have road, you have footpath, you have drain. The drain level of the drain is below the below the road, but the height of the footpath is above the road. So if road is 0, drain is minus L, and the footpath is plus L. So electrons can be either here or here or here. Just like that, I told you, if this is the road, it will be the center of the road. It is on the left side and it is on the right side. So when you place them in a magnetic field, when you do not separate them, energies of all the electrons are same. Moment you place in the magnetic field, you find they will separate into different layers. And this value will move from minus L to plus L. And all this having will integral values, and which includes 0 also. So if here in this case, if it is minus 1, this will be 0, this will be plus 1. Okay, so it will be 1. So now we are specific. Specific means what? Suppose one of your friend has seen you, he will tell that I have seen him in, suppose, say, dhan kheti. I have seen he is coming by a car with his father. So moment he says it is in dhan kheti, because your friend knows which road you come, so that is this. If it is dhan kheti, then this is L. And he will say that his father was driving on the right hand side of the road. That is this. Okay. So this is the orientation. So have you finished writing?
Yes, sir.
Okay. So again,
Sir.
I'll write down the, yes, please. Anyone who could not understand? Now I'll again write one chart. From there, it will be clear for you. Okay. So I'll write down here value of n, values of n, values of ml or n. All right. So let me write here 1. So what will be the value here? You know, it is 0. So for 0, what should I write here? 1s. Now, how many values this is going to have? How many values? For each value have L, it is going to have twice L plus 1 values. Twice L plus 1. So 2 into 1 plus 1 is what? Huh?
3.
2 into L plus 1.
3.
Yes, sir.
See here. What is S? What is the value of S? Okay. No. Value of S is 0. So what you will have now here? It will be, sorry, right now here, 2L plus 1. So S is what you know, S is equal to 0. So 2 into 0 plus 1 is what? 1. So what will be the value of ml? It will have one value. So that will be 0. So it will be 0 only. See, it is -1, 0, plus 1. So here only one value is there. What value I should take? Here I have to take 0. Now it is 2. So L will have how many values? L is going to have 2 values. For each value of n, L will have same number of values starting from 0. Okay, right. In bracket of 1. Now for this will have 2 values. It is 0 and 1. For 0, what should I write? 2. So what will be the value of ml? 2 into 0 plus 1, see? It will be 1. So it will be what? It will be 0. And for 1, it is equal to what? 2p. So what will be the value now here? 2 into 1, see? I am going by this plus 1. So it will be equal to what? It will be 2 into 1 plus 1 is equal to what? How many values will have? 3. So the here the value will be what? -1, 0, and plus 1. It will be -1, 0, and plus 1. So what I will write now here? Plus 1, 0, minus 1. All right. So what will be the name of the orbit here? What will be the name of the orbit? Ultimately, it is 1s. This is 2s. Now here we have found it has been split into 3 lines. So in that case, I'll write this is 2px, 2py, and 2pz. They are the suborbitals. Or so these are being named. Px, py, pz is being arbitrarily given. Yeah, after a few days, everything will be known to you. You don't get scared. Initially, 1-2 days will be difficult for you to find the name. So you should know that p orbitals are divided into 3 suborbitals. These are called x, y, and z. So we'll write 2px, 2py, 2pz. Have you finished writing?
Yes, sir.
Okay, now see here. Now we'll go to the third. So it will have how many values? 3 values. This is 0, This is 1 and this is 2. So now it is what? 3s. This is what? 3. So here it is what? 2 into 0 plus 1. So you do 1. So what we will call it now here? This will be, what will be the value of ml here? Value of ml is 0. How we are going to name it? We'll name same 3s. You can write here now. Name. Now this is going to have how many values? 2 into 1 plus 1 is equal to 3. So what are the values we'll have now here? Plus 1, 0, minus 1. What will be the name? Same. 3px, 3py, 3pz. So now this one I'll do it on the top. I cannot bend it for just it. Back pain. So I'll write it here. Okay. So I'll just bring it here. Okay. So when it is 2, what should I call it? You know 2 for stands for D. 3D. So what are the values this is going to have? It will have 3 values. Yes. So it will be it's going to have 3 values. It is 0, 1, and 2. Oh, no. You I have already written. Sorry. This two. I have already written this 2. So I'm gonna all go for this one. So now it will be named as D. How many values is going to have? Or what is the value of D? Is equal to 2. So it is 2 into 2 plus 1. So equal to what? 5. So is going to have 5. So it will vary from minus L to plus L. So now see here, what is the value of L? 2 only, 2. So it will be plus 2, plus 1, 0, minus 1, minus 2. So there will be some name will be there. We call it, here we are going to call it 3D, okay? XY, T, YZ, these are all subscript. 3D, ZX. No. I missed out this. So it will be 3ZX, 3D, X square minus Y square, and 3D Z square. These are all mathematically calculated. Initially, people have no idea. Mathematically, they have calculated, and after taking the spectra, they have found their assumption is 100% correct. So this is called science. Okay, nuclear chemistry, nuclear physics is the wonderful area where people assumed with their high level of imagination, and everything was found to be correct. So now what did you find? That we have found S orbital does not have any subshell. They do not have, they do not have any suborbital. P has 3 suborbitals, Px, Py, Pz. D has 5 suborbitals. Okay, finish it.
Done, sir.
Okay, now we'll go for 4. Quantum number 4. 4. It will have how many values? 4 values, starting from 0. So 0. So I'll now write directly here. Or you know it. So it will be 2 into 0 plus 1 is 1. So what is this? We will call it 3s. Sorry. When the value is 1, 2 into 1 plus 1 is equal to 3. So now you know it will be what? 0. So it is my plus 1, 0, minus 1. So what we'll write now here? 4px, 4py, 4p. All p are small. Then I go to d. So 2 into 2 plus 1, it is 5. So this will be what? Minus L to plus L. So what is the value of L? 2. So it will be plus 2, plus 1, 0, minus 1, minus 2. So I'll write now here, what is our orbit number? 4. So I'll write now here 4d xy, 4d yz, 4d zx, 4d x square minus y square, 4d x square. Write it, then I'll go for what is the other value? The other value is 3. See, and L will have same number of values of L. 1, 2, 3, 4. And L will have twice L plus ML will have twice L plus value. So we have already calculated. So you write it, then I'll go for the this one. Okay. So how many it will have now here? 2 into 3 plus 1. How many? 7. So it will have values from, what is the value of L? 3. So it will have values from minus 3 to plus 3. So I'll write now here plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus. This suborbitals also has name. Okay. But these names of this orbital in most of the book, it is not given. But I have somehow found it in one book and I have written down for you. You don't have to remember, but if you wish, you can find it. Okay, in your book. So these are okay. I'll write now here. It is 4. So you do 4 F. x into x square minus y square. Is it visible to you when I'm writing? Can you see?
Yes,
Huh?
sir.
Yes, sir.
Four f x. No, this is not x. This is y. X square minus y square. 4f z x square minus y square. This is 4 f x y z. Then next one is 4f z cube. Then 4f y z square. And this is 4f your information. You don't have to remember it.
Done, sir.
Now please remember one thing. All the electrons in an orbital like p orbital, f orbital, d orbital, they always remain together. When they remain together, their energies are same. But moment you place them in magnetic field, then they go to their respective area. Just like that, say in your school, you may have 2 or 3 sections are there. So when you are assembly and all these things, you all of you are remain together. But as the bell rings for your class, then you go to your respective classes, or in the same class, you sit in different benches. So this, when the electrons have the same energy, then we call that they are in the degenerate state. And moment you put it in a magnet, then these electrons which were together, immediately they spread up into different lines. Okay, then we call it the electron has lost their degeneracy. So now what we have learned? We have learned that principal quantum number tells us in which orbit the electron is moving. Moment you bring into picture the angular momentum quantum number, we have found that it describes us the location of the electron cloud where it is. And we have found there are four types of orbitals are there. What are those? They are S, P, D, and F. All right. And when you put them in magnetic field, we find these electrons of the orbital further get subdivided and goes to the different layer in the space, and these are called suborbitals. So we have found S does not have any suborbital. P has 3 suborbitals, Px, Py, Pz. D has 5 suborbitals. For up to D level, it is there in our syllabus. And F has 7 suborbitals. How to find? We find by the equation 2 twice L plus 1, where L is the value of angular momentum quantum number. So value of L for S is 0. So because of that, 2 into 0 plus 1, because of that we find S does not have any suborbitals. L value is 1, so 2 into 1 plus 1, that is totally equal to 3. So it has 3 suborbitals, Px, Py, Pz. D has the value of L for D is 2, so 2 into 2 plus 1, that is 5. That is, it has 5 suborbitals. And F orbital, the value is L is equal to 3, so 2 into 3 plus 1 is 7. So they have F has 7 suborbitals. Okay, I will take little bit more time because till now we have discussed only 3 quantum numbers, but altogether the 4 quantum numbers are there. See, we know when the Earth is revolving around in its orbit, it also moves around its own axis. Huh? Because of that, we find we have day and night. We know that Earth moves from west to east. All right. So because of its rotation on its own axis, we are having day and night. So similarly, when an electron, this is a nucleus, an electron is moving around in this orbit, this electron there is also moves around its own axis. So we do not know which way the electron is moving because these are not visible. So we can say it moves both in clockwise and anti-clockwise. And for that, because for movement also energy is required. So for that, an quantum number is being awarded to it. And that we call it spin quantum number. Okay. So we are going to now for spin quantum. This is the fourth. Spin quantum. So it is either written as ms or simply small s. Please remember, this quantum number is not derived from Schrodinger equation. Principal quantum number, angular momentum quantum number, and magnetic quantum, these 3 quantum numbers we derived mathematically from Schrodinger wave equation. What is that equation? H psi equal to E psi. But this is not being derived. This is being given by us arbitrarily with assumption. Okay. So what did you find here? Here we find that electron, when it moves around the orbit, it also spins around its own axis. Yes. The electron around the nucleus, it also moves around its own axis. Okay, we'll write here now. And anti-clockwise. So for this moment, no, we arbitrarily give a value. So for this moment, an arbitrary orbital bag. Okay, we'll write now here S orbital. Please remember S, P, D, these are all small letters. So I'll write now here 1s. This is 1s. It is a sphere. Here you'll find inside one is the electron will be there. Okay, this 1s. Now, for 2s, we know the size of the 2s will be bigger than 1s. But very interesting here, you'll find in 2s, there are two concentric spheres are there. See, please don't confuse that this is 1s. No. 1s is separate, 2s. We write here. 2s has two concentric. Concentric means what? Both of them, their center is same. Concentric sphere. Okay. So here you'll find the electron will be here. Here you'll find electron will be here. But in this middle space, no electron. Okay. And this is known as nodal plane. So nodal plane is the area where electron is not available. No. Nodal plane. Now we'll go for 3s. In 3s, there will be 3 spheres. Okay. 3s. So it has 3 concentric spheres. And how many nodal plane you will have? You have now 2 nodal plane. See, then you can theoretically calculate the number of nodal planes. It is equal to n minus 1. What is the n? Value of n is 1. So here 1 minus 1, 0. It is value of n is 2. So 2 minus 1, 1 nodal plane. Here value of n is 3. 3 minus 1, 2 nodal planes. So what we can write? S orbital has n-1 number of nodal planes. So if you go to 4s, 4 will have 4 concentric spheres and it will have 3 nodal planes. 4 minus 1. After finishing, please tell me.
Done, sir.
Done.
Okay, now we'll go for it is dumbbell shape. Okay, so now you know P has 3 suborbitals, Px, Py, and Pz. So I'm going to draw it now. So this is Z axis, this is X, this is Y. Okay, so this is Px orbital. Okay, this is Py. Okay, so this is Z orbital. Now, when all of them they remain together, so it will be Px, it will be Y. Please draw a little better than me. This is Pz.
Done, sir.
Done.
Okay. So now we'll go for d orbital. D orbital. These are double dumbbell shape. These I'll do separately. See here, this is XY plane. X, X, Y, Y. Okay, so how to understand XY plane? See here, look at this. This is X-axis and this is Y-axis and this is Z-axis. So this is XY plane. Okay. So here, in that case, you will find so this is D X Y. Say it is Y, Y, and Z, Z axis. So this will be D Y Z. Then say this is Z, this is Z. This is X and this is X. This is ZX orbital. Now this is X, this is X. This is Y, this is Y. See, these are in between the axis, this is along the axis. So this is D X square minus Y square. Okay. Now I'll draw everything together. This is Z, this is Z. This is X, this is Y. This is along the Z axis, and one is in the XY plane. It is just like a circle. So this is the Z axis, this is the other one. This is dz square.
So can you explain the last diagram again?
See, this one you have seen now. This one. This is along the D. This orbit is this. Okay. So this is the Z axis. This is X axis. This is Y axis. So it is like this. This is another orbit along the XY plane. Understood now? See,
Yes, sir.
this is the. See, dz square is also affectionately called as baby soother. You'll find some babies, they put a nipple type of thing in their mouth so that they should not cry. Plastic is there. Okay, so that because of that, DZ square is also called baby soother. Okay, then we'll meet you tomorrow.